Hello everyone, my name is V. Venkata Sai Krishna. Today we will discuss about a memory algo system. First, introduction. Recently, there has been a growing interest and demand for artificial intelligence and immersive media. These applications require high-performance devices to process a massive data. However, it is difficult to compute and transfer such a large amount of data in traditional non-human architecture because it consumes a significant power and dissipates its heat energy as a Moore's law and Dennard scaling reach physical limits. It is known that the data access and movement are the main bottleneck of a process field, and they consume more energy than computing itself. Thus, many studies about the near data processing are ongoing to overcome these challenges. Near data processing is applicable not only in traditional memories such as SRAM and DRAM, but also in more managing memories such as PCM, STT-MRAM, and ReRAM. These are also various attempts to reduce the data movements and overhead by computation offloading to storage devices. However, real-world applications are composite and diverse takes. Thus, there is a limit to solving the problems with an individual device level approach. In this paper, of a task for a real application scenarios are analyzed in the terms of a partition and the data movement over. Next, varieties of a RAM: static, fastest, most expensive user for a cache; dynamic RAM, SDRAM, synchronization DRAM, clock from bus and CPU; DD and SDRAM, double double data rate, transfer data on both edges of the clock. This is the figure of a embedded system memory types. Here we can see memory, and these are divided parts of a RAM, hybrid, and RDM or ROM.
DMC. In memory computing, also known as processing in memory, is a paradigm that places processing elements near or inside the memory in order to obtain fast memory access and high bandwidth. Among the various types of memory, this paper focuses in memory computing for DRAM, which is most widely used and has high density. There are two categories of in DRAM: computing depending on the package and the module assembly of the DRAM chip. That means computation in two-dimensional planar DRAM and computation in three-dimensional stacked DRAM. In 2D planar DRAM, processing elements reside in the DRAM die as shown in figure. Since data travel through on-chip interconnection on the DRAM disk, it is free from off-chip I/O constraints, and also it can achieve high parallelism by exploiting the bit line of subarray or root buffer and internal data line. However, there are some difficulties in computing in 2D planar DRAM because the DRAM fan manufacturing process is optimized for low cost and low leakage. Only simple logic can be placed due to bulky and slow transitions. The standard logic process is optimized to deal with complex logic functions but requires frequent refresh operations due to the current leaky characteristics. This leads to high power consumption and poor performance. In order to overcome these drawbacks, there have been attempts to add separate chips for processing elements over the 2D planar DRAM chip in the dual inline memory module DIMM, that means DIMM. However, additional assembly process is required and cost is consequently increased. On the contrary, 3D stacked DRAM such as high bandwidth memory and hybrid memory cube can use the DRAM process and standard logic process together because they pile up more than 2 days. Therefore, more complex processing elements can be located on the base die with the standard logic process as shown in figure. You can see in next figures. Even though the physical interface PHY through silicon via and IEEE 1500 area for test pins and circuits occupy the basic bit, there is still extra space that can be used for other purposes. These are the block diagram is of in-memory computing structure. Examples: 2D planar DRAM such as DIMM type and B 3D stacked DRAM.
Myself M. Vijay. In storage computing ideas, some computation are uploaded to the storage device. There was study in which hard disk drive HDD used for processor compute uploaded task for ISC. However, HDD were quickly replaced by solid state drives SSD. After SSD were introduced to the conventional SSD does not process to even though they have embedded process. The internal structure of SSD in shown figure. The SSD consists non-volatile NAND flash chip that do not lose data regardless of power loss, and an embedded process such as the ARM process to manage the firmware such as the flash translate layer FLT. The main concept of SSD based on ISC, that is SSD regard a small computer with a embedded process to run program with the storage device. ISD increase the system performance because storage device can handle tasks parallel with the block diagram of SSD for in storage computing. If the task such a query processing, list insertion, scan and join, Hadoop, MapReduce, and search engine are uploaded to the embedded process in SSD, which improve the processing speed and energy efficiency. Not only did other studies employs an embedded process, but they also introduce additional implementations of FPGA GPU in the SSD. However, they have scientification disadvantage as such modification of the SSD structure, resulting in additional cost.